Hey there. So now we've learned about, sorry, I'm messing with my writing utensil. Um, we've learned about solutions. We're going to talk about solutions basically from here on forward. Um, a lot of a lot of what we're going to do is dependent on how much of our solute is in our solution, right? And so in order to really make sense of this, we need to talk about concentration and concentration units. How do we measure what's in our solution? Because when we do a chemical reaction, remember when we talked about equilibrium and rate, right? Those things depend very much on how much of our product is in solution, how much of our reactant is in solution, and how does that change over time. So we need a way to measure this stuff, and I have just the thing. All right, concentration. Concentration units. So there's four different ways that we're going to measure concentration. Some of these we won't really measure, we won't use them very often, but it's good to know them uh, just for now. The first one is going to be percent by weight. So if you have a solution and you take grams of your solute and divide it by 100 grams of solution, right? That's going to give you percent by weight. So how many, if you have 100 grams of your solution, which is a mixture of your solute and your solvent, how many grams of that is your solute? Right? So an example of this would be, let's say that we take 28 grams of sodium chloride and we dissolve in 200 milliliters of water. Okay, so first of all, water has a density of 1, and so 200 milliliters of water is 200 grams of water. Right, so this is 200 grams of water. And so if we add these together, we get 228, and that is the number of grams of our solution. Right? Then we divide by the grams of our solute, and we get, what do we get? We get 12% by weight, or by mass, I should say. I shouldn't say weight, should I? Because I'm a scientist. Right, so if you divide these two, you get 0.12. I just multiplied that by 100 to take care of this 100, and yeah, it gives me 12% by mass. Right, so if you're calculating percent by weight, you take the mass of the solute divided by the mass of the solution and convert it to a percentage. Okay, very straightforward. Similar to that are things like parts per million. Right, so parts per million, or ppm, you'll often see this in environmental chemistry, analytical chemistry, where people are trying to identify very, very small amounts of things, right? Parts per million is the milligrams of solute divided by liters of solvent. So notice that now we're dealing with the solvent itself instead of the whole solution, and usually that's because the amount of solute is so minuscule that we don't really need to consider it in our thing. So let's say that we take, I don't know, let's do 6.3 milligrams of something, I don't know, we'll say lead. 6.3 milligrams of lead, and that is dissolved in 375 milliliters of water. So to figure out parts per million, we take 6.3, divide it by liters of water. So we have to convert milliliters to liters. We divide this by 1,000, and we get 0.375. So now we've got 6.3 milligrams per 0.375 liters, and that gives us 17 parts per million. This is usually the part where someone asks me about significant figures. I don't understand significant figures. Don't tell anybody. So I probably won't ever count you wrong for significant figures. I usually just deal in whole numbers or however many decimal points feel right to me. So that's not something I'm going to care about, just so you know. Okay, onward. Let's see. We've got parts per million, we got percent by weight. Both of these, of course, deal with the mass of the solute. So we have grams of solute and milligrams of solute here. And then we're getting some kind of volume, whether it's liters or whether it's the mass of the solution, right? The other thing that we can measure is instead of measuring the mass of the solute, we can measure moles of the solute. So there's two ways that we can do that. The first is molarity. Molarity is the one that we will use the most. This one gets a blue star. Molarity is the version that we'll use the most. So let's go back to our example of 28 grams of sodium chloride in 200 milliliters of water. Okay. What we're going to do for molarity is molarity is equal to the moles of solute divided by the liters of solvent. Okay. So you're all excited that we get to calculate moles again. Remember, for moles, we need molecular weight. The molecular weight of sodium chloride is, I wrote it down, 58.44 grams per mole. Pretend that that's a G, grams per mole. So in order to figure this out, we take 28 grams divided by 58.44 grams per mole, and we get 0.479 moles. And then to figure out the molarity, we take 0.479, oh my goodness, 479 moles divided by 0.2 liters, right? So we converted milliliters to liters, again, just by dividing by 1,000. I didn't show my work there. And when we divide these two out, we get 2.4 molarity. 2.4 molar solution. Right? So this is just a different way of describing it. It is still a 12% by weight or 12% by mass solution, but it's also a 2.4 molar solution. Like I said, this molarity, this is what we're going to deal with for the most part, especially when we talk about equilibrium and rates and that kind of stuff. So we're going to use molarity a lot. So remember, if we have a mass, we need to convert it to moles, dividing by the molecular weight. And if we have a volume, we need to put it in liters. Okay. All right, let's see here. The last concentration unit is molality. Okay. And molality equals, I wrote it down, moles of solvent or solute divided by kilograms of solvent. All right, so this is worthwhile if you're using a solvent other than water, right? If you're using water, then the kilograms and the liters are going to be the same. So for most aqueous solutions, anything in water, your molarity and your molality are going to be very similar because liters and kilograms are more or less interchangeable. But if we have a different density of our solvent, then molality might be different. Let's take, we're going to take 4 grams of something, chemical X, and we're going to divide it in, or we're going to dissolve in, what did I miss? There it is. I was like, I need a volume here. 350 milliliters of solvent. And that solvent has a density of 0.975. Just to kind of, I'm just kind of making up numbers. We'll need a molecular weight for our chemical X. I guess I'm going to make chemical X be 342 grams per mole. Again, these are all numbers I just kind of made up before I started, so not that big of a deal. So the first thing we need to do is we need to convert to moles of solute. So we do that the same way we did before. 4 grams divided by 342 grams per mole equals 0.0 117 moles. And now we need kilograms of solvent. So we have milliliters of solvent. We can convert that to grams of solvent by just multiplying these two things together. 0.975 times 0.350, because this is kilograms per liter. I should have put this in here. Hang on, I'm going to erase some stuff and bring it back. I forgot my units. Kilograms per liter times 0.350 liters. Right, so liters will cancel out, and we get a number for kilograms, 0.341 kilograms. So moles per kilogram, we just got to divide these two, 0.0117 divided by 0.341 equals 0.034 molal. I think that's right. For some reason that doesn't look right to me. I'm going to double check it on my calculator. Yeah, it worked out great. All right, trust the calculator. All right, so that would be the molality there. So we have 4 different concentration units. We have percent by mass, we have parts per million, we have molarity, and we have molality. So make sure that you have the ways to calculate all of those in your head. There's a concentration units worksheet that's linked on D2L that you should definitely try out. It'll be good practice for just kind of working through these things. What are the types of questions you might get asked? What are the types of calculations you're going to have to do? So work through those. Make sure that those make sense. That'll be something that we'll probably touch on in either the Friday meeting or maybe next Monday. But concentration will be one of the things that you're going to see on quizzes and exams very soon. All right. I'm not sure what's next. I haven't looked that far ahead. So there will be another thing, and I think it has to do with phase changes. So we'll go back to phase changes and look at that in context of solutions. So look forward to that.